Hello and welcome to Allot 360. I'm here today with Moti Goldshtein, Allot Smart AVP of Product Management, and we'll be talking about network congestion and what CSPs can do about it to manage the traffic in their networks. Although Moti, when I hear traffic congestion, I think like most people, I think about my commute to and from work and the fact that there are just too many cars on the highway. How does that apply to the world of CSPs?
Well, Michael, that is a good analogy, actually, using the word traffic, double meaning as it is. And that is correct because CSPs are building networks. And those networks are being used by the end users, creating traffic. And at a certain point, the amount of traffic is more than the capacity of the network that was built, and congestion is being created. This can either be something temporarily for a few seconds or milliseconds, and it can be sometimes for a long periods of time, like those rush hour at the commute hour traffic, but also in the networks when you have like peak hours where everybody are watching Netflix and sitting and browsing and so on and so forth. So yeah, it has to do with both. And managing the congestion is one of the key values that we provide, and it's a very interesting discussion to do.
So I guess the motor traffic analogy is useful up to a point, but can you explain a little bit more about what congestion really is in the network of the CSP?
Of course, yeah. When we talk about, sometimes we hear the words congestion and we hear oversubscription. Basically, those are similar but different in that sense that in many cases, the way that networks are being built, they are inherently oversubscribed, right? I'm getting fiber to the home, you're getting, my apartment next door are getting, but my entire building is also getting 1 gig for the entire building because they rely on the statistical nature of traffic. Even when we are watching video and in our head we think about, it's a constant stream of bits. No, it's not. There are variable bitrate codecs and adaptive bitrates, and the traffic itself may be bursty, and I start to browse a page, so you get traffic coming in, and then you read it, so it slows down. So everything is moving in and out, and when you look into those statistics, you can say that we can share the access, we can share the media, we can share those traffic tubes or the traffic lane, if you want to think about it like cars filling up the road. But at a certain point, the demand is more than the capacity. Then congestion happens. This could be, as I said previously, a temporary event, just now, and not just by shaping the traffic in a sense that will give some gaps, it could be enough. And if it prolongs for a long period of time, then you need to do something about it.
Okay, so Moti, if we continue with this driving analogy, when I'm driving and it's rush hour and there's a traffic jam, I'm frustrated, I get annoyed, I'm sitting in traffic, maybe I'm honking if I'm an annoying driver, but definitely it's taking me longer to get where I want to go, and I'm not happy with the experience. What happens in a network situation?
It's very much alike in the sense that in modern network, you are not only talking about the specific APIs, we're still using them, but now we're talking more about the perceived quality of experience and not only quality of service, because it has to do with how you as a user is perceiving this congestion, perceiving the experience you are receiving. And if you think about yourself, or when I think about my daughters, it's like they don't really care what's the length of the buffer when they are watching YouTube. But they do care a lot if they are pressing the video and it takes more than 2 seconds to start. So the time to play, it's a key factor. For my experience, or in that sense, for their experience, I can wait for 3 seconds, maybe 4, okay? So when you talk about managing congestion, you always have to keep in mind the quality of experience and how to manage that in a good way. And here comes a lot of tools, and we see a lot of CSPs thinking about that, want to improve that so their customers will be happier and stay with them for longer times.
So if we continue again with this driving analogy.
I like this analogy.
Yeah. So there's a lot of road work that takes place. They add lanes, or maybe they allocate certain lanes to certain kinds of traffic, like carpool lanes or mass transit lanes. And those are kind of fixed solutions. But if there's a traffic jam because there are too many regular cars, those extra lanes don't really help. How does that kind of approach, or does that kind of approach apply to service providers as well?
Yeah, so if we continue with that analogy, you can say that the same applies, and there are many strategies. Now, the first one, it's like, and you have to do it in some cases, is simply to add capacity. When CSPs are moving from 4G to 5G, they add capacity because it's more efficient. You can have more bit per hertz and go to higher speeds in those lanes. If you had more fiber cables and optic cables in the ground, you had more capacity, and so on and so forth. And this is like, let's say, maybe a brute force solution. It can help, but it is costly and it takes a lot of time. Having said that, there are many other strategies that you can apply in the network, and the network evolves.
So you mentioned the adding capacity as a slower solution, long-term, perhaps brute force. But like you said, it doesn't apply to what's happening today. There's a network, it's got a certain capacity, and traffic is growing, and they're not ready to roll out additional capacity. It's expensive, it's time-consuming. What can they do in an almost real-time dynamic way to deal with problems that come up unexpectedly that they haven't yet planned for?
Well, there are multiple solutions you can apply, let's say multiple strategies, and we can kind of scale them up in regards to the granularity of the interval they applied for, okay? You may start with, let's say, the classic approach in which you define a policy. For example, I'm saying that in my network, YouTube and Netflix and Amazon Prime, or let's say streaming services, has higher priority than peer-to-peer. I define that, and I have the DPI services in my network allocate regarding to this priority I define. It's something you do, you apply to the network, and it is there, let's say, forever until you change it. So this is on one scale. It's a very effective, very easy to manage and straightforward approach. And there are many others which I can elaborate later, but all the way to having able to define and to perform action on an event by event basis. So you can scale the solution on this scale on regards to the granularity of time they apply to. And you can actually mix some of them in the same network depending where is your problem.
So when you talk about the event by event basis, as opposed to the type of service that's streaming, what kind of events would you be looking at?
Think about yourself when you're doing any type of interactive activity or browsing or watching video. There are many events, and when you watch, let's take the video, it's I think the easiest one. You're watching a movie or a clip. It's a different type of experience when you're pressing the video, as we talked before, and you need to wait for it to buffer. You have this percentage going up or this sandwich going down. Now you can wait for a few parts of a second, but you won't wait for a few seconds. It's too much. Okay? So this is one type of event, time to play. When you are watching a video, there are many things going on. The buffering, it sends traffic, and type of frames and so on. You as a user don't care about it. You do care if the video stalls. So this is a different type of event, like stall. If the resolution is changing, all of these parameters has a huge effect on your experience. While traditional KPIs has to do with the bitrate you see, what type of bitrate, this can significantly change depending on the codec you are using and which device you're watching, if it's the mobile or 4K or 8K TV and so on. So there are many events like that, opening a browser, rolling down and so on, which have a different effect on your perceived quality of experience.
And so if you can measure those events, then you can give different priority at different points in the flow of the service.
Exactly that. And here we are starting to divert from the commute and the cars and traffic. So imagine the different events you could take different actions upon them and prioritize them based on the service you wish to provide. So this can enable CSPs to differentiate themselves. That's the other way of knowing, not commoditize themselves, differentiate themselves and provide differential services, maybe to have a specific service for gamers and others for streamers and the third one for business and so on. In many cases, some consider it like the holy grail of internet services.
Well, this is very much what we saw in our 2021 survey, where we queried 100 mobile operators around the world, and they had sort of a consensus that users like gamers and streamers would be willing to pay a premium if they got higher quality, guaranteed SLA, higher quality services. They would pay more, they would stay more loyal, and generate more revenue for the CSPs. So CSPs understand that there is this value in managing congestion dynamically.
Yeah, I agree. And this is what we see both from the survey you mentioned and from our customers and from the market need. And obviously we see the industry going towards this type of tiered services and those more innovative concepts when you can slice your network, for example, in 5G to different types of services and virtualize them in a sense that enables you to both provide differential services to the market, to guarantee quality of experience, to monitor it, and to dynamically allocate resources on a packet by packet basis.
So you mentioned that there's this spectrum of solutions from the a priori static all the way to the dynamic event, finely granular solutions. What's in the middle? What other kinds of solutions can be applied to solve congestion?
Yeah, I'm happy that you raised that. That's a good one because there are many strategies and many solutions along the way. And let's continue when starting off. Okay, I define the policy and I know how to control the traffic. It's very important to distinguish the fact that although the policy itself can be static, it will only apply when a congestion arises. Okay, so before congestion, I have all the traffic, everybody can get what they want. There's no policing to be done. Once I'm reaching the limits, this is where the quality of service starts to kick in, So you're doing it very dynamically on a packet by packet basis, but it's a static policy. Now you may think that in a network you can define different policies based on, for example, time of day. It's add a certain amount of dynamic to a network. Think about residential network, usually between, let's say, 2 a.m. to 7 a.m. Traffic is off-peak hours, so some of our customers define the policy differently throughout the night to allow, for example, more peer-to-peer. So you can download, upgrade, update, backup in those hours very easily. And you as a user don't care. For you, the perceived quality of experience for backing up it just needs to take place.
Right.
Okay? So this is another mean of dynamic or another solution that can be applied. In some cases, we see networks which are a bit more complicated and a bit more advanced when they have a certain policy they want to apply to the overall traffic, meaning browsing is more important than streaming, peer-to-peer and VPNs are at the lowest priority, for example. But they have some subscribers, let's say business, which they want to have higher priority for browsing and business application and really best effort for streaming, because this is and they both live concurrently. So you may want to have an orthogonal policy, not define the application on a network-wide, but have a different policy, orthogonal policy on a per subscriber basis. This is an additional capability and more complex way. So we start, having it more complex and having a connecting granular application identification with users. And there's a secret sauce on how to do it in a right way and to streamline the operation. But at the end of the day, it needs to flow throughout the system in the right way. And later on, you have some of those tubes, in a road, the lanes are defined and the length of the road is defined, so the capacity is known. In some of the networks, the capacity of those tubes is unknown. Think about a wireless network, okay, a wireless access. It may differ due to rain or to different link budgets or the state you are, those lines you have on your cell. So the capacity always changing, constantly changing. So if you have the ability to track those changes and identify when congestion is happening and then apply the right policy, then you are much more advanced. So it's another, now we are getting more than 3 dimensions in that sense. And as we discussed previously, you have those event-driven approach in which you identify specific events and apply action on those events, not on the entire connection. And these things can actually coexist. Right. Now, not all of them together, it's unmanageable, but to some extent you can combine multiple, like exclude some of the traffic, manage it as a whole, have the others track down the total bandwidth, identify congestion, apply policy, use event-driven, dynamic QoE. All of this together can enable at the end of the day for the CSPs to be cost-effective, provides a high-grade service so that their end users will be satisfied, will have a good quality of experience. So it's a win-win-win situation in that sense.
Sounds great. Wow, this is pretty cutting edge. Thank you for explaining this. It sounds like there are a lot of things that service providers can do to handle congestion, and a lot of things that Allot can do to help them. Thank you, Moti, and thank you all for watching another episode of Allot 360.